Hello. In this video we're going to see a few basic characteristics of vectors, and we're going to answer a few questions regarding vector addition in 2 or 3 dimensions. Let's start with the definition of vectors and scalars. Scalars are quantities that only have magnitude, and vectors are quantities that have magnitude and direction. For example, when we're saying that the temperature is 35 degrees Celsius, this is just a number, this is just the magnitude of the quantity of temperature. So temperature is a scalar. From the information that temperature is 35 degrees Celsius, we understand whatever we need to understand. But when I say that I push something with a force of 5 Newton, I don't get the whole picture, because I need to know where this object is moving, where I'm pushing towards. So in order for the information to be complete, I need to say that a force is 5 Newton to the right or 5 Newton to the left. So force is a vector. Vectors are represented by arrows, and the length is proportional to the magnitude of the vector. This means that if I have a force that I draw it like this and another force that I draw it like this with 2 arrows, then the F1 has a relatively small value and F2 has a relatively great value. So F1 could be, for example, 5 Newton and F2 could be 10 Newton. The length is proportional to the value, to the magnitude of the vector. Now, a few important vectors in physics are position, displacement, acceleration, force, velocity, and momentum. And a few important scalars that we need to have in mind are the quantities that only have magnitude, for example, time, distance, mass, speed, and energy. It's good to know that a vector can be represented in 2 or 3 dimensions with an arrow. The 2 dimensions are x and y, and the 3rd dimension is the z dimension. X means the direction right or left, y means the direction up or down, and z is the direction in or out of the screen. And there are 3 unit vectors in these 3 axes. The 3 unit vectors in these 3 axes, we call them I, j, and k hat. Any vector can be represented with the notation that a vector A is a value ax on the x-axis plus a value ay on the y-axis plus a value az on the z-axis. So we can express any vector in this notation. And if we need to find what is the value, what is the magnitude of the vector, all we need to do is apply the Pythagoras theorem in 2 or 3 dimensions in order to find the value of the magnitude. Also, one reason why we're using the unit vector notation is in order for us to be able to add or subtract 2 vectors on the 2 or 3 dimensions. So the sum of a vector A and the vector B is basically the sum of their x components times the unit vector I plus the sum of the y components times the unit vector j plus the sum of the z vector components times the unit vector k. In a similar way, we can find the difference between 2 vectors by subtracting the x, y, and z components, and each one will be multiplied by the unit vector I, j, or k. Now, let's answer a few example questions. For example, we have 2 vectors that express 2 different displacements. Displacement 1, that we can see, it is 15i minus 30j plus 12k, and displacement 2, that it is minus 13i plus 26j minus 7k. And we need to figure out what is the resultant vector of these 2 displacements, and we need to find the magnitude of the resultant. So the resultant means that we need to add these 2 displacements, and if we need to add the 2 displacements, then we will add only the I components, then the j components, and then the k components. So we open a bracket and we say it is 15 plus negative 13 I plus negative 30 plus 26 j inside the bracket, and then 12 plus negative 7k. And the final expression is 2i plus minus 4j plus 5k. If we want also, we can express this as 2i minus 4j plus 5k. And in order to find the magnitude of the resultant, the magnitude is the absolute value of the displacement delta r1 plus delta r2. We apply the Pythagoras theorem with all the components, so 2 to the power of 2 plus negative 4 to the power of 2, and we have to be a little bit careful, we need to apply the bracket, we need to apply the power in the whole negative 4, plus 5 to the power of 2, and you will give me 1 minute for the calculations. The result is 3 root of 5 or 6.7. In a similar way, we're going to do 2 or 3 more examples. We have two vectors a and b, and we need to find the sum of these vectors and then the difference of these vectors. Now, in order to find the sum of vector a and b, all we need to do is add the components, so 6i plus 6 plus 2, 8j plus minus 3 plus 1, the result is negative 2k, and we can remove the bracket from this term, so minus 2k. And I think that we see the answer as A. Now for the difference, we need to subtract 2 minus 4, so minus 2i, plus 6 minus 2, 2j, and then minus 3 minus 1, so minus 4k. And I think we see that the best answer is B. We can continue, and I can give you 1 minute to pause and think about the answer for the sum of the two vectors A and B. And we can try to figure out what is the expression in the unit vector notation. So vector A plus B is equal 3 plus 2. Now the unit vectors, usually we call them with the I, J, K notation, but in a similar way we can say unit vector on the x-axis, unit vector on the y-axis, and unit vector on the z-axis. So in this case we're using this x hat notation plus 1 minus 3y plus minus 5 minus 6 z hat. So we have 5x minus 2y minus 11z. And I believe that the next question is the last example. I can give you 1 minute to think about this. So we have 3 vectors that we need to add and then find the magnitude of their value. So we can say that A plus B plus C will be the sum of the I components. So 1 plus 3 minus 1i plus the sum of the y components. So plus 4 minus 1 plus 1. So plus 4 minus 1 plus 1j, and then the sum of the y component, of the k components, so minus 1 minus 4. So we have 3i plus 4j minus 5k. However, the question is about finding the magnitude of this summation. So the magnitude of A plus B plus C is root of 3 to the power of 2 plus 4 to the power of 2 plus, a little bit careful, negative 5 and all of it in a bracket to the power of 2. So if we do the math, I believe we're going to find a root of 16 plus, root of 9 plus 16 plus 25. So this is root of 50. And root of 50, it is 5 root of 2. Thank you for watching. Feel free to ask any question on the comments.